All right, so today we're going to be talking about two variable inequalities. So this is pretty much your usual equation of a line, but instead of an equal sign, there's going to be an inequality. So a linear equality, so linear inequality, is an inequality where it was two variables whose graph is a region on the coordinate plane. So it's not just a line, it's a region that the line makes. So the boundary is what the line is called, and then half plane is the shaded region that satisfies the inequality. So it divides it in half, even though if on your graph it may look like it's shifted off to the 1, it really has divided the graph into half because it goes on to infinity or negative infinity. Okay, so let's just recap here. If you have a less than or greater than symbol, remember this from Algebra 1, you're going to have a dashed line. If you have a less than or equal to or greater than or equal to, it is a solid line. Okay, so what is the graph of each inequality? Letter A, we have y is less than or equal to x plus 2. So let's just start graphing it like we would a normal line. So go ahead and put a dot on your y-intercept, which is 2. And then the slope is 1, so up 1 over 1, up 1 over 1 a few times. Okay, is this going to be a solid or a dashed line? Well, it's going to be a dashed line. So this one you can't use your straight line tool, you have to actually graph it. So there it is. And then now is the tricky part. So I've known some people who struggle with the shortcut I'm going to show you. So I'm just going to show you the tried and true method that always works. If you cannot remember the shortcut, that's okay. So take a point and test it. So I'm going to take the point 0, 0 because it's really easy to use. So 0, 0 right here. And I'm going to test it to see if that's the direction that my graph needs to be shaded, if it needs to be shaded on that side of the dashed line. So I'm going to plug in 0 for my x and my y, because it's 0, 0. And then let's test it. Is 0 less than 2? Well, yes, it is. So that will be the direction that I shade my line. So it will be all right here. Let's make this a little bit bigger. So this will be my area that is shaded. So this is the half plane that works. Okay, that was the way if you can't remember the shortcut. Here is the shortcut. Your symbol is less than. So, and this only works if the y is on the left side of the equation or the inequality. So the y has to be on the left. If it's less than, you'll shade below the line. If it's greater than, you will shade above. But again, the y has to be on the left. The y must be on the left. Okay? And by itself. All right, we have another one right here. So we have y is greater than or equal to 1/3 x minus 2. So let's graph it. Your y-intercept is negative 2. Then let's go up 1 over 3, up 1 over 3. So this is going to be a solid line because it is greater than or equal to. So here we go, like something like that. Okay, so let's use the trick now, or try to use the trick. This right here, the y's on the left, that is greater than. Oh, what happened to my line? Sorry, I gotta fix that. Maybe. Sorry. Try this again. Okay, there it goes. So greater than. So if it is greater than, we're going to be shading above the line. So it's right here. All of this area right here. So don't take your time. You don't have to shade it perfectly. So that is your answer for this. If you wanted to double check to make sure, you would pick a test point. If I can, I always like to pick 0, 0 because it just is easier to handle zeros. So is 0 greater than or equal to 1/3 times 0 minus 2. Well, is 0 greater than or equal to -2? Yes, it is. It's greater than. So that works. So that point worked. So, and that makes sense because it's in our area that we shaded. All right, this next one, y is greater than -2x plus 3. Let's go ahead and plot our line. So we have +3, up 2 over 1, up 2 over 1. Oh, I'm sorry, it's negative slope, my bad. So it's down 2 over 1. Down 2 over 1. And this will be a dashed line. So let's go ahead and see if I can draw this. It's a little crazy, I'm sorry, but that's as good as it gets right now. So y is greater than is that symbol. So the greater than, you're going to shade above the line. So it's going to be all of this area right there. And that's it. The next one, y is less than or equal to 3x minus 3. Go to -3. This one is a positive slope, so up 3 over 1. It's going to be a solid line. Sorry, my lines are not very good today. Okay, so we've got that done. Now the shading part, well, y is less than or equal to, so you'll be shading below. So on this one, the point 0, 0 doesn't work. So let's pick, in case you wanted to, pick a different point. How about the point, I don't know, let's say 4, 0. Let's pick this point right here, 4, 0. And if we plug it in, it should work. So that's the point 4, 0. So I'm going to plug in 4 for my x, 3 times 4 minus 3. Okay, and then 0 was my y coordinate, so I'm going to put that there. Is 0 less than or equal to 12 minus 3? Is 0 less than or equal to 9? Yes, it is. Say you did pick 0, 0, the origin for this one, and you plugged in 0, 0. Is 0 less than or equal to 3 times 0 minus 3? 0 less than or equal to -3? No, it is not. So that point does not work. So that's why we didn't shade that part. So that's how it works. If you want to use that method, I'm cool with it. Or if you can keep the shortcut straight, you can do that. All right. Can you do the same thing with the absolute value equations? The answer is yes, you can. Don't freak out. You'll be fine. It's pretty much the same thing. So, what is the graph of the following inequalities? Y is less than the absolute value of x. Well, that looks like the parent function to me. But instead of a solid line like we're used to, we're going to have a dashed line. No big deal. We can do it. So it's at the origin with slopes of 1 and -1. So then I'm going to have to try to draw. It's not terrible. So we've got that one. That one's a little worse, but okay. You get the idea. So there is the graph of y is the absolute value of x. But we have to shade. So it's the exact same thing. If you wanted to test a point, you could. But I'm going to do the shortcut first. So that point, or that symbol, is less than, so we are going to be shading below. So it is all of this region right here. Okay, so if you wanted to test a point, let's test the point. Let's do this one. So that point is 0, -2. So is -2 less than the absolute value of 0? Is -2 less than 0? Yes, it is. So that point did work. So maybe you wanted to use the shortcut, but you like to check your work using this. That is perfectly fine with me. All right, the next one. This is going to be a solid line, so that's good. So this tells you this is a reflection, right, because of that negative. It has a stretch by factor of 2. And then it's shifted up 4. So go up 4. And it's reflected, so it's going to be upside down. And the slopes of the lines are going to be 2 and -2. So right there, here, and here. It's going to be a solid line. All right, and now we need to shade. So y is greater than or equal to, so it would be above this. So all of this area up here. And that's your answer. All right, so now we're almost done. Write the inequality based on the graph. So this graph, let's just start with it. Before we put the symbol in, well, we can go ahead and put the symbol in. It'll be y, so y is, if you're shading above and it's a dashed line, it's going to be greater than. All right, now let's leave some space in case we need it. Well, we know it's going to be a negative out front. Looks like the slope of each line is 1, so we don't need there's no scale factor, or a factor. So that's okay, because there's no shrink or stretch. And then it looks like the vertex is at -2, 1. So that would be x plus 2. And then on the outside, plus 1. And that would be your answer. All right, the next one. Looks like this vertex is at 3, -2. Again, there's no, looks like the slopes are 1 and -1, so we're good there. So I'm going to have y is, well, what would this one be? Greater than again, because it's shaded above, greater than. So absolute value, because there's no reflection and no stretch or shrink. So x, how do I show shifted right 3? Well, that would be -3. And then, oh, that's a -2. So down 2 would be -2 on the outside. And I gave you all the same. So this graph is also shaded above, and it's a dashed line. So it's going to be greater than again. Okay, so we're going to have, and it's a reflection. And it looks like this one has a shrink or a stretch. So it looks like, ooh, this is a little different. So this one, this coordinate right here, what does this look like to you? Looks like to me it's going to be -3 and then positive. If each one is counting by 2. Do you see that? So this would be 1 right here. And this would be 3. And that would be 4. This looks like it's at 3. So the graph's at -3, 3, or the vertex is. All right. And now I take it back what I said about a shrink or a stretch. Looks like to me it's going down 1 over 1, because this graph is counting by 2, or yeah, counting by 2s. So those look like it is down 1 over 1. So I take it back. There is no shrink or stretch. So it's just going to be negative out front. You could put -1. You don't need to. And then we got to write the vertex. So if we go left 3, that'll be a +3. And then up 3. So +3 on the outside. And that is your answer. So on these, you have to be careful to see what they are graphing the x-axis and y-axis by, what they're counting by, 1s or 2s, or maybe it's something else. I don't know. All right. Thank you for watching, and I hope you have a great day.